Hi and welcome to this video where I'm going to be explaining some of the different types of solids which make an appearance in the NCEA standard, which we generally call structure and bonding. So this is really a very brief overview about those types of solids and identifying them and their properties. There will be more detailed videos on each of these specifically. Okay, so first thing you need to know, there are 4 types of solids that are going to come up in this standard. And they are ionic solids or ionic compounds, which you should be familiar with from level 1. Metallic solids, which, as the name kind of implies, are metals. So you may be familiar with those if you did the metals standard in year 11. Covalent network solids, which we'll talk about. Covalent network solids are basically large, giant molecules. So it can be things like diamond, or it can be things like polymers as well. And molecular solids. So these are things that are molecules. So if you've done organic chemistry, then pretty much all of the things that you come across in organic chemistry are molecules, other than the polymers, which tend to count as covalent network solids. Okay, so just a little bit more detail. Okay, so ionic solids, you can always identify ionic solids because they are made up of metal atoms or metal ions really, and non-metal ions. If you think about your periodic table, think about where those elements sit on the periodic table. Metals are pretty much everything except the top right-hand corner. That's where you find your non-metals. Okay, so ionic solids, metals and non-metals. Metallic compounds, as the name implies, are made up of metal atoms only. So you'll find metal atoms, like I said, through the majority of the periodic table, everything except for that top right-hand corner above that zigzaggy line that you often see on your periodic table. So basically, there's only about 15 or so elements that are not metals. They are hydrogen and helium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Silicon is a metalloid, so it sort of sits in the middle, and then phosphorus, sulfur, chlorine, and argon are non-metals. Arsenic again sits somewhere in the middle, but selenium, bromine, and krypton are not metals, nor are iodine or radon or astatine or whichever the other one is that I cannot read from here. Okay, so those are your non-metals. If it's not one of those, it's a metal. Now, covalent network solids, there are a lot of these, but the only ones that you really need to be aware of at level 2 in this standard are diamond, graphite, and quartz or silica dioxide. So they're the only ones you really need to worry about, and we'll talk about those specifically later. And then molecules, or covalent molecules, all molecules have covalent bonding in them, I might add, are made up of non-metal atoms only. Okay, so ionic solids, metallic solids, covalent network solids, and molecules, right? All metals, all non-metals, or a mixture of both, depending on which way you're going. All right, so those are the 4 types of solids that we're going to deal with in this topic. And I just want to think a little bit about the properties of those substances for just 1 minute or 2. Okay, so first off, ionic solids. And when you're thinking about the properties of ionic solids, think about the most common ionic solid in your life. That is salt, right? The stuff that you sprinkle on your fish and chips in the afternoon. Okay, it has a moderate to high boiling point and melting point. Now, I would consider a high melting and boiling point to be anything much over 1,000 degrees Celsius. Most ionic solids would fit in the 500 to 1,000 degree range. Now they do vary, of course, but most of them will sit in that range, so I'd call it moderately high. Ionic solids are brittle, they're crystals, right? If you whack them with a hammer, they will shatter. Most ionic solids, and again, not all, but most, dissolve in water. If you take a solid pile of an ionic solid like salt and you stick 2 electrical leads into it, nothing will happen. It will not conduct electricity as a solid, but it will conduct electricity when it's dissolved in water or melted. And you can melt pretty much any ionic solid if you can get it hot enough. Okay, next I want you to think about metals, and think about, again, a metal that's common or that you've seen before or that you're familiar with. I would recommend something like copper or silver, gold, because, but you could think about steel or aluminium or anything like that. Okay. Again, they have moderately high melting and boiling points. The majority of metals would melt at temperatures sort of 500 to 1,000 degrees. Some of them are much higher than that, some of them are lower, but most of them would fall in that range. They tend to be ductile and malleable. Now, ductile means you can pull it out into a wire, and malleable means you can bend it. So metallic solids tend to be able to do that. They don't dissolve in water. As you know, if you're wearing a piece of metal jewellery, when you wash your hands in the sink, your jewellery does not dissolve. They do conduct electricity. That's why all our wires are made of copper. Okay, so those are some of the properties of metals. Covalent network solids. Again, for this, I would think about either diamond or perhaps quartz, which is actually what you find in window glass as well. So very high melting and boiling points. You think about how high you'd have to get it to melt a diamond. It's very, very hot. They're very hard. They don't tend to be either malleable or brittle because you can't bend them. And they don't break easily, or at least only if you hit them in the right places. Can be a little bit brittle sometimes, but not a lot. They don't dissolve in water, and they don't conduct electricity in general. The only exception is graphite, and we will talk about that later. And finally, we have molecular compounds, of which there are a lot, and their properties really are quite variable and much harder to put a general kind of a rule on. But they have typically lower melting and boiling points. Most of the things that you know of that are gases or liquids at room temperature are going to be molecular compounds. So they tend to fall in those ranges. It's very hard to describe them as whether they're malleable or brittle. Those tend to be words that we use with them very often because most of them aren't solid at room temperature. So calling them molecular solids, well, everything can be a solid if you make it cold enough, but anyway. Their solubility in water varies, and of course water is itself a molecular compound. Solubility will vary, so some things can be easily soluble in water, some things are not. They don't tend to conduct electricity. So this is the basic overview of the types of solids and their basic properties. I'll look at this in more detail in further videos where we look at each one individually. But for now, I'll wrap that up. Thank you very much, and I will see you again later.